So let's look at another example problem where we need to find the surface area of a triangular prism. But this triangular prism is a little bit more irregular. It's not going to have these rectangular faces that are all the same size. So it's not as symmetric as the previous example we looked at. And remember, with surface area, we're just trying to find the total area that the outside of the shape takes up. So essentially, we need the area of the triangular face in front and in back, and those are going to be the same since this is a prism. So remember, with a prism, that you can imagine taking your base, this triangular face, and sliding it back along the length. And if you were to cut out the cross section at any point along the length, then that would also be the same size triangle. And I didn't draw that perfectly, but you can get the general idea. So that means that this triangle, as you slide it back, perfectly fits along the length of this, and the back face would be the same as the front. So we know those are going to be equal to each other, and then we got to find the area of each of these rectangular sides. So this is 10 by 14. This side right here, this is also going to be 10 by 14 since it's 14 meters long and this length is 10. But this bottom rectangle, that's a different size. That is a 12 by 14 rectangle. So we have three rectangles, two of which are equal, and we have two triangular faces, which are both equal. And if we add all of those together, the area of all of those together, then we'll get the total surface area. And I should clarify, we don't actually have meters here. So this side length is just 14, or we can say 14 units. So let's set up our equation for surface area, which we'll just call SA. So we have two triangles. So we want twice the area of this front triangle, since it's the same as the back. And the area of a triangle is half the base, so half of 12 multiplied by the height, which is 8. And then from there, we have two rectangles that are going to be equal to each other. So we can add those to the total here for surface area. And those are each 10 by 14 rectangles. And I'll just use the dot for multiplication here. And then lastly, we have the rectangle on the bottom, and there's only one of them, so that's just a 12 by 14 rectangle. So if we add all of this together after simplifying, that will give us the total surface area of this. So let's start calculating. Since we're taking two of these triangular areas, we can cancel out the 2 with the 1/2, and then we just have 12 times 8. So 10 times 8 is 80, 2 times 8 is 16, so that's 96. And since these are all units, we'd be multiplying units by units, so this is really just square units. And then here we have two of these rectangles, so now we're talking about this rectangle and the other one on the other side. So those are 10 by 14, so that's 140 square units, and we're doubling that. So that's 280 square units. And we'll add that to the rectangle on the bottom, this 12 by 14 rectangle. So we can do 10 times 14, that's 140. 2 times 14 is 28. 140 plus 28 is 168. And again, we have square units there. Now we can add all three of them together to find our total surface area. And when you add all of these together, your total surface area would be 544 square units. Since we weren't given a specific unit, we can just call this square units. And since we are talking about the total area, we're not talking about the volume, how much space the inside takes up, we know it should be square units rather than cubic units.